Okay, class, number 46 is sum of an infinite geometric series. So in order to do that, we're going to look at our formula sheet over here. Where is it? Okay, sum of an infinite geometric series. So we're going to be using this thing. Well, let's go back to that. We're going to be using this guy right here. Okay, just this portion, not all this. Okay, just this. So what does the a sub 1 means? Well, this right here, that means that I need my first term. Okay, first term. Then the r, that represents the common ratio. Okay, so that means what's going on from each term. Okay, what's the common difference if it was arithmetic. Okay, but here that's going to be geometric, so that means it's multiplying by a common ratio. Now this is only whenever we've got an like it's going down and it's being a fraction. Okay, so when the r is less than 1. Okay, like if the common ratio is a fraction. So let's go back and let's see if we can set these guys up. Shh. Okay, so watch this. Here's 1, and it goes all the way. Okay, so we first have to come up with our first term. So what is our first term? Because remember, the formula is the first term, and then you have 1 minus the common ratio. Now I know I could do this because I'm thinking the common ratio between both of them might be less than a fraction. Let's see. Okay, so 1 in here, my first position, 1. So 3/5 to the first power, that's just going to be 3/5. Okay, now what is 3/5? 3/5 to the second power? Yeah, 9 over 25. All right. Now, how do we figure out if there's going to be a common difference between these? Well, what we got to do is take this first one, which is 9 over 25, and we have to divide it. We have to divide it by this first one. So this is 3 over 25. Okay? So if you divide the second from the first, imagine like this. Like if it was going like this, 2, then 4, then 8. All we'd have to do is to figure out what the common ratio was. We'd take the 4 and divide it by 2, and then we'd see, oh, it's 2. Okay? So here, I'm going to take the second term, divide it by this term. So that means I got to multiply by, so then this is going to be 20. Oh, 3 over 5, excuse me. Thank you. Okay, so that's 3 over 5. So that changes things then. Okay, so that's a 5, so that's 5 up top. And then the 3's on the bottom. Okay, so 3 goes into 9 3 times. Okay, and then 5 goes into 25 5 times. So that means that we do have a fraction. So the common ratio is a fraction. So that means that we can use this formula. Okay, and we can actually find the sum. Because if it's bigger than a fraction, then you can't find the sum. It doesn't exist. Okay, so all I got to do is just do that. Okay, so the first term is 3/5. Okay, let me give myself some room. I don't know why I started talking like I was Irish or something. Give me some room, or I can't even do it. Okay, so watch, 3/5, and then that's 1 minus, and then the common thing is that we're multiplying by 3/5, so that's going to be 3 over 5. So then from here, this needs to be added, so we're going to take this guy and we're going to multiply this by 5 and that top by 5. So we have 5 minus 3, which is 2. So 3 over 5 and then 2 over 5. Multiply by the reciprocal. So I'm going to backflip this guy. And that's 5 over 2. The 5's cancel and we're left with 3 over 2. All right, so the sum of this first one is 3 over 2. All right, let's find one that doesn't have. Let's try maybe part B. Let's see if B is going to have like a weird thing. Okay, so this one goes from 1 all the way to infinity, so that means it's an infinite. And it's geometric, so that means it's going to have a common ratio. So let's figure out what the first couple terms are, and then we can find the common difference. So if I put a 1 right here, 4 to the first power, that's going to be 4. 4 times 3, that's going to be 12. Now if I do 2, 4 to the second power, that's 16. And then 16 times 3, that's 48. So then we go 48 divided by 12 to find the common ratio. And we see that it's going to end up being bigger. Sorry, I just hit the microphone. We see that that's going to end up being bigger than a fraction. So here, the common ratio is bigger than a fraction. So then it's going to, I mean, think about it. As this thing increases, each time we're going to be multiplying by 4. So 48 times 4. And if we have to add up all these things, this is just going to get to infinity. So we really can't come up with an actual and exact number. So then we would say either it doesn't have one, so it doesn't exist in this case, or it's infinity. Okay, we don't know what the number is. So that's how you do that. I would say try C and D and see if you're just finding out the common ratio. Okay.